Let's now start coding the AI for the enemy character, and this is in fact more involved than you may at first think. One of the key features of the artificial intelligence for this character is whether or not this enemy character that we can see here in the scene, so whether this Ethan character here, the key question is, can this Ethan character see the player character? Now of course, we don't know the answer to that question at any particular time. It could be that during gameplay, this character can see the player sometimes, but not at others. We need a mechanism to determine whether the enemy character can see the player at any moment in time. Now, to achieve this, we need to answer that question in multiple stages, and we're going to do that using a combination of the components that we add to this character, as well as a script file. So I'm going to select the Ethan character here in the scene viewport. Now, of course, any kind of character that can see has a range or has a line of sight. That is, has a complete radius around them in which they cannot see beyond. For example, this enemy character may be able to see out to this distance around here, around the wall area, but they won't be able to see further. That's not because the wall is there. Even if I move the character outside here, there would still be some kind of distance or limit beyond which they cannot see things, their horizon of their view. So I want to get started at creating the horizon of their view, which initially I'm going to code as a sphere that surrounds the character. So that's going to represent the range of their view. So to do that, I'm going to select the Ethan character here and move to the component menu and choose component. Then I'm going to select physics, and then I'll choose sphere collider and click that from the menu here. So the sphere component, or the sphere collider component, is now added to this Ethan object. I want to make sure that this is marked as a trigger, and that is simply because I don't want the player to be able to bump into that object as though it were a collider. It's only going to act as a region, or marking out the volume inside which this enemy character can see. Now of course right now it's down here by the feet and it's far too small, so I want to increase the radius of this object here. So I'm going to expand this to maybe somewhere around here to mark out that region. So this is the region inside which the character can potentially see. If the player were to leave this region, then under no circumstances could they be seen by the enemy character because their view doesn't stretch that far. Now of course, to accompany this collider here, I'm going to need to create a completely new script file that I'm going to attach to the enemy object. So I'm going to come down here to the project panel in the line of sight folder and right click and choose create, and then choose C# script. I will name the script line sight because really that's what we're going to be encoding here, and drag and drop that onto the enemy character. I'm going to select the Ethan here so you can see that the script has been added. In fact, the script hasn't been added, so let me try that again. I'm going to drag and drop that onto the Ethan character, and there we have line of sight functionality added to this character. I'm going to double click on this to open this script file inside MonoDevelop here and just bring that into view. So to determine when the player character enters the viewing volume, all we need to do is to add a new function to here. In fact, I'm going to remove the update and start functions because we don't need those. So I'm going to bring down here and we have a function which is onTriggerStay. Now the onTriggerStay function can be written as void onTriggerStay, like so. And then inside here, well, this actually requires an argument, which is going to be a collider. That is a reference to the collider that enters the trigger. And right now, just to confirm that this code is happening here, I'm going to use a debug statement. So I'm just going to print the name of the object that enters the collider here and press Ctrl S on the keyboard to save that code, and then just return back to Unity here. That will compile the code. Temporarily, I'm going to grab the FPS controller and just move this out to one side here. And when I press the play button on the toolbar to play the level, you can see that the first person controller falls down. But what I'm going to do is move the game tab and the scene tab side by side and switch to the console so that I can see the messages that are printed there. Now when I press the play button on the toolbar, the controller still falls down into the depths here. But if I grab that controller and I bring it up into the scene, let's just pause the scene here. and I grab this with my translate tool. So let's grab the first person controller and bring that way up into the scene. In fact, I'll center that at the world origin just to bring that into view here. So now it is inside that collider. And if I resume playback, suddenly we get the FPS controller name printed to the console, indicating that we have detected which object has entered the collider using the onTrigger stay function. Notice that the onTrigger stay function is executed every single frame for as long as this object is inside that collider. If I were to bring this outside the collider here, way out into the distance, that function is no longer called here. So I can clear the console and we aren't going to get any more because the object has left the collider. So here we have the ability to determine when the player character has entered a certain range around the enemy. Of course, it could be that the player is standing behind the enemy and the enemy doesn't actually see the player. We need to address that issue next.